Welcome back everyone. So now we're in the part 3 of our discussion of integrals yielding inverse trigonometric function. So today we're going to discuss example 5 to example number 9. Example number 5. Evaluate the integral of dx over x squared plus 10x plus 30. So as we can see, the integral contains a trinomial x squared plus 10x plus 30. So for the evaluation of this kind of integral, which contains a trinomial of the form ax squared plus bx plus c equal to 0, so we need to complete a perfect square trinomial. So what is a perfect square trinomial? A perfect square trinomial is in the form of a squared plus 2ab plus b squared. By factoring, we have a plus b times a plus b, so that is equal to a plus b squared. And the other form is a squared minus 2ab plus b squared, or a minus b times a minus b, or equal to a minus b squared. To complete a perfect square trinomial, we will use the method of completing the square. So in this method, we take the quadratic equation ax squared plus bx plus c. So next is divide the all terms by the coefficient of x squared. So the coefficient of x squared is a. So we have x squared plus b over ax plus c over a. Next is to move the number term to the right side of the equation. So the number term is the c over a. So we have x squared plus b over ax equal to negative c over a. The next is to take the coefficient of x, which is b over a. So for b over a, so we will divide it by 2. So we have b over 2a, then squared. So that is b squared over 4a squared. So the next is to complete the square on the left side of the equation. So by adding this b squared over 4a squared, and balance this by adding the same value to the right side of the equation. So we have x squared plus b over ax plus b squared over 4a squared, so equal to b squared over 4a squared minus c over a. The left side of the equation is a perfect square trinomial. So we can transform this into x plus b over 2a squared. Then transpose the two terms from right side to the left side. So we have plus c over a minus b squared minus 4a squared. For number 5, so take the trinomial x squared plus 10x plus 30. So by completing the square, so transpose 30 to the right side of the equation. So x squared plus 10x equal to negative 30. The next, take the coefficient of x, divide it by 2, then square it. Then the resulting value must be added to the both sides of the equation. So x squared plus 10x plus 25 is equal to negative 30 plus 25. X squared plus 10x plus 25 is a perfect square trinomial. So we can transform it into a square of binomial. So x plus 5 squared equal to negative 30 plus 25. So negative 5. Then transpose, we have x plus 5 squared plus 5. So x squared plus 10x plus 30 is equivalent to x plus 5 squared plus 5. Then next, so rewrite the integral. So we have integral of dx over x plus 5 squared plus 5. Then next, solve for the value of a and solve for the value of u. So a squared is equal to 5. And get the square root of both sides. So a is equal to square root of 5. Then next, u squared so equal to x plus 5 squared. Then get the square root of both sides. So u is equal to x plus 5. Differentiate, we have du is equal to dx. And substitute, so we have integral of dx, so that is du over 5, so that is a squared, plus x plus 5 squared, so that is 2 squared. Then we have the integral of du over a squared plus 2 squared. So integrate, we have 1 over a times the arctangent of u over a plus c. Then substitute the value of u and a. So 1 over square root of 5 times the arctangent of u, that is x plus 5 over a, so square root of 5 and plus c. So the answer is 1 over square root of 5 times the arctangent of x plus 5 over square root of 5 plus c. Example number 6. So evaluate the integral of dx over square root of 20 plus 8x minus x squared. So first, so rewrite the integral. So we have the integral of dx over square root of negative x squared plus 8x plus 20. Next, factor out the negative sign. We have integral of dx over square root of negative times x squared minus 8x minus 20. Then, we have the trinomial x squared minus 8x minus 20. So by completing the square, so transpose negative 20. So x squared minus 8x equal to 20. And take the coefficient of x, divide it by 2. So Negative 8 divided by 2, negative 4, then squared, and positive 16. Then add it to the both sides of the equation. So x squared minus 8x plus 16 is equal to 20 plus 16. Then x squared minus 8x plus 16 is a perfect square trinomial. So we can transform it into a square of binomial. So we have x minus 4 squared equal to 36. Then transpose 36 to the left side of the equation. We have x minus 4 squared minus 36. So x squared minus 8x minus 20 is equivalent to x minus 4 squared minus 36. So our new integral will be integral of dx over square root of negative times x minus 4 squared minus 36. Then distribute the negative sign. So we have integral of dx over 36 minus x minus 4 squared. So next step is to solve for a and u. So a squared is equal to 36. So get the square root of both sides. So a is equal to 6. Then u squared, so equal to x minus 4 squared. Then get the square root of both sides. So u is equal to x minus 4. Differentiate. So du is equal to dx. Then we have integral of dx, so that is du over square root of 36, so that is a squared minus x minus 4 squared, so u squared. So integrate du over square root of a squared minus u squared. So we have arc sine of u over a plus c. Then substitute the value of u and a. So arc sine u, so x minus 4 over a, so over 6 plus c. So the answer is arc sine of x minus 4 over 6 plus c. Number 7, evaluate the integral of square root of arctan x over 1 plus x squared dx. So if the inverse trigonometric function is present in the integrand, its differential should be there too, to be able to carry out the integration process using the substitution method. For this example, so let u equal to arctangent of x, differentiate, so du equal to 1 over 1 plus x squared dx. Then we have integral of square root of u d, or integral of u raised to 1 half d. Integrate, so using simple power formula, so we have u raised to 1 half plus 1 all over 1 half plus 1 plus c. Or we have u raised to 3 over 2 over 3 over 2 plus c. Simplify, we have 2/3 of u raised to 3 over 2 plus c. Then substitute the value of u. So we have 2 over 3 times arctan of x raised to 3 over 2 plus c. Number 8, evaluate the integral of secant x times tangent x over 9 plus 4 secant squared x dx. So first is to solve for the value of a and the value of u. So a squared is equal to 9. So get the square root of both sides. So a is equal to 3. Next, u squared is equal to 4 secant squared x, or u squared is equal to 2 secant x squared. Then get the square root of both sides. So u is equal to 2 secant x. Then differentiate. So du is equal to 2. Derivative of secant x is secant x times tangent x dx. Then divide both sides by 2. So du over 2 is equal to, cancel, secant x tangent x dx. Then rewrite the integral. So we have integral of secant x tangent x dx is equal to du over 2. So du over 2 over 9. So 9 is a squared plus 4 secant squared x is u squared. Then we have the integral of du over 2 over a squared plus u squared. So next, apply the constant multiple rule. So we have 1/2 times the integral of du over a squared plus u squared. Integrate. So 1/2 times the integral of du over a squared plus u squared. So that is 1 over a times arctangent of u over a plus c. So 1/2 times 1 over a times arctangent of u over a plus c. Then substitute the value of a. So 1/2 times a is 3. So 1 over 3 times arctangent of u. So 2 secant x over a. So 3 plus c. Simplify. So that is 1 over 6 times arctangent of 2 secant x over 3 plus c. Number 9, evaluate the integral of e raised to x over square root of 1 minus e raised to 2x dx. So first, solve for the value of a and u. So a squared is equal to 1. Square root of both sides, so a is equal to 1. And next, u squared. So that is equal to e raised to 2x, or u squared is equal to e raised to x squared. And get the square root of both sides, so u is equal to e raised to x. Differentiate, so du is equal to e raised to x dx. Then we have the integral of e raised to x dx is du over square root of 1, so that is a squared, minus e raised to 2x, so that is u squared. Integrate, so we have arc sine of u over a plus c. Then substitute the value of u and a. So arc sine e raised to x plus c.